Hello, in this video I'm going to go over volume of cubes and cuboids, but to start with we're going to just review what we did last time on area and perimeter. So as a starter I'd like you to work out the area of these shapes. So we have a square, a rectangle and then a triangle. So pause the video, have a go, and then when you're ready for the answers, press play. Here are the answers. So for the first shape we have a square. And the area of a square is simply length times width. And obviously for a square, the length and the width are identical. So we simply have 5 multiplied by 5, which is 25. And don't forget the units, centimeters squared, because we are in centimeters. The second shape is a rectangle. And once again, the area is going to be length times width. And we can see that it has a length of 8 meters and a width of 3 meters. So we just need to do 8 multiplied by 3. So the area is going to be 24. And pay attention to the units. The lengths are measured in meters, so the area is in meters squared. Finally, we need to work out the area of the triangle. Now, the area of a triangle is simply base times height over 2. So you work out the base and the height, you multiply them, and then you halve your answer. So we are going to do base, so I'll just do it in steps. So the base of the triangle is 10, the height is 3, so we are going to do 10 times 3, which is 30, and then we're going to halve that. Now, half of 30 is 15. So our final answer there for the area is 15 centimeters squared. So what I would like us to do is just recap compound shapes briefly. So I'd like us to find the perimeter of this compound shape. And remember, a compound shape is just a shape made up of smaller shapes. So we could say, this compound shape is made up of these two rectangles here. So if you just pause the video, have a go, and when you're ready for the answer, or when you're ready for a hint, press play, and then you can have another go. So if you are struggling to find the perimeter, so remember perimeter, if you want to work out the perimeter of a shape, you simply add up all of the sides. Of the shape. You are looking for the distance all the way around it. It's like if you have a fence, a fence around a field, how long is the fence? Now, for this shape, we know most of the sides, but there are 2 sides that are unknown. So we need to work out a way of finding these missing sides so that we can add up all of the sides of the shape. So, if we look at this missing side here, we should be able to see it's going to be 9 take away 3, which is 6 meters, and this missing side here is also going to be 3 meters, sorry, because I'm just looking at 9 take away 3, that will give us 6, and then 7 take away 4, that will give us 3. So now we know all of the sides of the shape. So all that remains is to add all of the sides up. So to work out the perimeter, I'm going to do 9 meters, and when I've done it, I'm going to circle it. So I've got 9, I can leave the units to the end. 9 plus 7, I like to go clockwise, plus 3, plus 3, plus 6, plus 4. And that will be the perimeter. So let's see what that works out to be. So 9 plus 7 is 16. 3 plus 3 is 6. 6 plus 4 is 10. So I'm going to have 16 plus 6, which is 22, plus 10 is 32. So that means the perimeter is going to be 32. Now, these lengths were in meters, so 32 meters. It could be some sort of playing field, or, well, maybe not playing field quite, it wouldn't be quite big enough for that, but it could be some sort of garden area or something like that. So, yeah, so we can ignore the animation there, that's just work on the area. So what we're going to do now is look at how to find the area of this compound shape. So I'd like you to try it. So I'm just going to give you a hint first. We could split the shape up maybe into two rectangles, A and B. So can you then, obviously we need to have the length of A. So the length of A, as we've discussed, is going to be 6 meters, and that will help you. So can you pause the video, have a go at finding the area, and when you're ready for the answer, please press play. So here are the answers. We can look at the area of shape A, length times width, 4 times 6, 24 meters squared. Then we can consider shape B, length times width is 7 times 3, 21 meters squared. And then the total area is going to be those two values added up, which is 45 meters squared. So we have now considered area and perimeter. So we've considered 2D shapes. Now we're going to start looking at 3D shapes. So we're going to consider the volume of cubes and cuboids. So it looks like I have a rectangle and a square on my screen, but if I just rotate them, we can actually see these are 3D shapes. I've got a cuboid on the left and a cube on the right. Let's just review what that means. So please bear with me one moment. So if we look here, we can see the cuboid is sort of like a 3D rectangle. So it's like, you can see it's got 6 faces, all of them are rectangles. We can see that not all of the lengths are equal. So that would be a cuboid. And then a cube is very much like a cuboid, but it's just that it has all of the sides are the same. All the sides are the same. So all of those sides are equal. So the volume of a cuboid, well, we can, back in primary school, you would have used you would have used centimeter cube blocks to work out the volume of something. You would have just counted how many centimeter cube blocks make up the object, similar to how we looked at centimeter square blocks last time. But the volume of a cuboid is length times width times height. That is how we work out the volume of a cuboid. And the volume is just the amount of 3D space that the shape takes up. So, there's a nice way of thinking about it. If you have a bath, filled with water, and then you put like you try and submerge a 3D shape in it, the volume of water that will go up, the volume of water that will be displaced, we say, is equal to the volume of the shape that we put into the water. So we're going to do some examples. Example 1, find the volume of the cuboids. So all I need to do here is sub my numbers in. Volume is length times width times height. Now here the length of the cuboid is just 6 centimeters. Basically, the 3 dimensions, the 3 measurements, we just times together for the volume. But we can say the length is 6, the width is 4 centimeters, and the height is 2. So bearing in mind, the units have all got to be the same. They've all got to be in centimeters, or they've all got to be in meters, and so on. Now, when I multiply these, I've got 3 numbers. It might be a bit tricky to multiply 3 numbers, so I'll start off by doing 6 times 4. 6, 12, 18, 24. And then I've still got the times 2, so I need to do 24 times 2, which is just going to be 48. So the volume there is 48, and the units of volume are centimeters cubed, because you are timesing 3 things together. Example 2, we are given a cuboid with a volume of 36 centimeters cubed, a width of 2 centimeters, so I'll label that on, and a length of 6 centimeters. Now, we do not know what the height is, and we want to find that out. So I'm going to write the formula. Volume is equal to length, and I'm just going to use L for length, times width, times height. And then I'm going to substitute in what I know. So I know the volume is 36 centimeters cubed. So instead of volume, I can write 36. Instead of length, I can write 6. Instead of width, I can write 2. Now, instead of h, I'm just going to have to put a box because I do not know what that height is. So let's carry on. Let's work out what we know. I've got 36 is equal to 6 times 2, which is 12, times by whatever number has got to be in that box. Now, you need to think to yourself, what number do I times 12 by to get 36? Well, the same question is how many 12s are in 36? And that's 3. So the number in that box needs to be 3. Just think about it. 12 times 3 is 36. So the number in the box needs to be 3, which means that the height is 3 centimeters. So we've considered the volume of a cuboid. So let's have a look at cubes. So I've got 2 examples of cubes in red and blue. So I've got a cube with sides 3 centimeters, and I've got a cube with sides 5 centimeters. A cube is basically a cuboid, and all of the sides are equal. So in exams, you might see a cube, and you can tell that it's a cube because they might only write one of the sides on. So they'll just say that's 5 centimeters. All of the other sides then we can assume are also 5 centimeters. So I'd like us to work out the volume of the cube for example 1. So a cube, and you can see I've only labeled that 4 centimeters on, and we know that it's a cube, so that means all of the other sides are going to be 4 centimeters. Now, a cube is just a cuboid where all of the sides are equal. So to work out the volume, we simply use length times width times height, but the length, the width, and the height are all going to be 4. So I just need to do 4 times 4 times 4. Now, 4 times 4 times 4, to work that out, I'm going to start by doing 4 times 4, which is 16, and then I'm going to times by 4. Now, we might not know that offhand, so we can use our column method or our grid to do 16 times 4. Now, 4 times 6, 24. 4 times 1 is 4, plus the 2 is 6. So I end up with 64 centimeters cubed. So that cube there is made up of 64 of these centimeter cube. We could think of it as being made up of 64 of these little centimeter cube blocks. So that's how we'd work out the volume of that cube. But a lot of the time with cubes, they won't give you a picture. You'll have to work it out. So for example 2, we need to work out the volume of the cube with sides 40 centimeters. So we could draw a picture to help us if we wanted to. Basically be a cube, so a square face, and I just do parallel lines. Not very well, I'm not the best at drawing. All of the sides are equal. So I've got width of 40 centimeters, I've got a length of 40 centimeters, and a height of 40 centimeters. So it doesn't really matter what we label them as, length, width, and height. We just know the dimensions, the 3 measurements are 40 centimeters. So if I want to work out the volume, we simply need to do length 40 times width 40 times height 40. So we need to do 40 times 40 times 40. Now, to do that, I can basically say I've got 4 times 4 times 4, and then 10 times 10 times 10, because 40 is 4 times 10. So it's like I'm doing 4 times 10 times 4 times 10 times 4 times 10. But 4 times 10 times 4 times 10 times 4 times 10, I can just times in any order. So I can think of that as 4 times 4 times 4 times 10 times 10 times 10. 4 times 4 times 4, we know from the first question, is 64. 10 times 10 times 10 is just 1,000. So I've got 64 times 1,000, which is just going to be 64,000 centimeters cubed. And that about covers what we need to do on volumes and cubes and cuboids. So what I would like you to do now that you've watched the video and hopefully tried some of the questions yourself, I would like you to go on to Maths Watch and then complete 10B3 volumes of cubes and cuboids. And if you finish that and there's still time left in the lesson, I would like you then to finish anything which is unfinished from yesterday. Or not from yesterday, from Tuesday, the areas and perimeters work. So make sure all of that is complete, please.